dear students, after a long time we are again here. Now, as you know that before this situation we were discussing about few topics, that is drugs acting on respiratory system, and then the topic was autocoids and the digestive system, drugs acting on the digestive system. Now today we are going to discuss the autocoids. Now you can see this figure. Now before discussing in detail, first of all you must have a clear concept about the autocoids regarding this figure. Now what are the autocoids? Autocoids and their related drugs. The autocoids are simply, they are the local hormones, means that they perform a function for a short duration of time. They are synthesized in the cell, perform their function and degrade it out. Now that's why we can say that these are the local hormones. Now how they are synthesized, how they are released, and after releasing they perform their physiological and pharmacological activity, which we will discuss later on. First of all, according to this figure, now you have to know about this, that how these the autocoids are synthesized. Now before going to discuss, just I have told you that these are the local hormones. These are the local hormones. Now again, the local hormones, this is the figure. This is the figure you can see here. Now this figure is nothing but it is known as mast cell. They are known as mast cell because all these autocoids, particularly the most important is the histamine. It is synthesized in the mast cell. Now you can see that this black color shows the cell membrane, mast cell membrane. These are the vesicles. These are the vesicles in blue color. In this blue color having the dots or the spots, these dots are actually the granules. Now you know that these autocoids or the histamine, it is stored in the granules. It is stored in the granules and then released by these granules by means of certain process that is known as exocytosis. Now how this histamine is released? This histamine which is synthesized in the mast cell. Now the release of histamine takes place after the action, that is antigen-antibody reaction. When there is antigen-antibody reaction takes place, there is release of this histamine or the kind of autocoids. Now this cell membrane having, you can see there is black colored Y-shaped figure in the figure. This is known as the receptor, and these receptors are nothing which are known as Fc receptor, because we have discussed in detail about these receptors. Now Fc receptor, they are according to chemical composition, they are known as G protein coupled receptor, which again you know about in detail about the G coupled receptor. Now these G coupled receptors, they are present on the mast cell membrane. Antigen comes and they combines with the receptor. Antigen comes and they combine with the receptor. After the combination, there is a protein which is known as T protein, that is transmembrane protein kinase. Transmembrane protein kinase. Now this transmembrane protein kinase then activated. This activation of transmembrane protein kinase then activate the phosphoinositol diphosphate. Phosphoinositol diphosphate can activate the inositol triphosphate. Now I have discussed about these because you know that phosphoinositol triphosphate and diacylglycerol, these are the second messenger. Calcium is the second messenger, and they are required for various pharmacological and physiological functions. Now when there is activation of the inositol triphosphate, they are responsible to release the calcium ions. They are responsible to release the calcium ions. Now what is the role of calcium ions here? The role of calcium ions, that they participate in the process of exocytosis. Now what is exocytosis? Exocytosis means when there are combining of the two membranes, there is rupturing of the membrane takes place and there is release of the granules having the histamine, the release of the histamine from the granules, and that process is known as exocytosis. That is known as exocytosis. Now this is the antigen. This is the antigen actually in this form. They act upon the receptor, which are nothing but the Fc receptor or the G protein coupled receptor. They combine with this, activate the T protein kinase or the transmembrane protein kinase. Then there is activation of phosphoenol triphosphate. Phosphoenol triphosphate releases the calcium ions. When there is release of calcium ion, there is rupturing of the vesicle membrane. This is the rupturing of vesicle membrane, and there is release of the histamine. That histamine which is stored in the granules in the vesicle then released, and then you can see here that this granule having the histamine, that is usually it is present as protein histamine or the heparin histamine. Protein histamine or the heparin histamine. Now you can see protein having negatively charged, histamine having positively charged. So when there is release of histamine, it is the positively charged or the basic component or basic amino acid. Basic amino acid. Now for the exchange of this, there is exchange of cation takes place between the sodium calcium and the cation exchange. Sodium and calcium, they combine with these granules, and there is release of the histamine. There is release of the histamine. Now this histamine, that is histamine. Now how this histamine is produced in our body, how it is synthesized. Now you can see that the synthesis of histamine takes place by means of the amino acid. That amino acid is known as histidine. This histidine, when decarboxylated, there is formation of histamine. Now let's start the autocoids in detail. I think that you have you followed the figure which just I have shown you. Now autocoids, it is the word which comes from the Greek. Autos means self, a cause means the self function or the function of the component as in local form. That is known as autocoids. Now these are the substances produced inside the cell. They are present or synthesized inside the cell, perform their function in the cell, and then destroyed within the cell. That's why they are known as local hormone. Now, so that is the physiological and pathological conditions such as injury, immunological processes. Immunological processes means when there is antigen antibody reaction takes place, there is release of these components. Now there are three types of this. Either they are the amine autocoids, lipid derivative, or the peptide autocoids. Now first of all, amine autocoids. These are the histamine, 5-phytoxytryptamine, lipid derivatives, prostaglandins, leukotrienes, platelets, activator factor. Now third is the peptide autocoids, that is bradykinin. Right? Now coming to the first member of this autocoid, which is the most important, that is the histamine. That is known as histamine. Now histamine present and synthesized in the mast cell. In the mast cell they are synthesized. The organ which are responsible for the synthesis or the sites where the mast cells are present and they can synthesize the histamine, they are the skin, gastric glands, intestinal mucosa, lungs and liver. Here these are the sites or organs where the histamine can be synthesized. Now the synthesis, how this histamine can be synthesized? Histamine can be synthesized by the histamine. Histidine is an amino acid. You know that we have studied in detail about all the amino acids, their metabolism, their structure, their function in the body. So here just I come to inform you that histidine is that the precursor of the component histamine. Now this histamine, that is histamine, this is the histamine. Now here you can see that how the histamine is formed. The histamine can be formed by the process of decarboxylation of the histidine. Now in case here you can see this is the carbon dioxide. When it is present at the side chain, then it is known as histidine. When there is removal of this carbon dioxide takes place, the amine is formed, and that amine is known as histidine converted into histamine. This is known as histamine. Now as you know that every component, every drug, every hormone having its own particular receptor, and when they combine with the receptor, they show their action. So similarly, histamine also having its receptors, and that is scheduled in 1966. They are known as there are only two receptors has been formed, H1 and H2. These are the two receptors which are performed by the research of H and Shield. So H1 and H2 receptor. In 1983, because research is going on, further receptors are formed. Further receptors are found in the body for the histamine. In 1983, a third one, that is H3 receptors, are identified. In 2001, H4 receptors, and these H4 receptors are located in the brain and intestine. Now, the storage and release, as you know that in the first slide, in the first transparency, when there was a figure in which there is first synthesis of the histamine takes place, storage of the histamine takes place, release of the histamine by means of the process of exocytosis takes place, and then there is the action of the histamine. So storage and release we have discussed in figure. Now coming to the pharmacological action of histamine. Pharmacological action of histamine, first of all on the blood vessels, that is on the blood vessels there is dilatation of the blood vessel. Due to the dilatation, you know that I told you that whenever there is dilatation of the blood vessels, there is flushing. There is flushing, and when there is dilatation of the blood vessel, there is fall in the blood pressure. There is fall in the blood pressure. Increased heart rate when given subcutaneously. When this histamine given to the patient subcutaneously, that is to the skin, then there is the increase in the heart rate with a little or no fall in the blood pressure, right? So it also causes the increase in the vascular permeability. Now you know that histamine is that component which causes the allergic reaction, and I have told you in my previous lectures various times that whenever there is allergic reactions takes place, there is the symptoms of the allergy, that is there is redness, there is swelling or the edema, there is pain, and there is increase in the body temperature. So these are the four important symptoms of the allergic condition. So in this way, why there is edema occurs due to histamine. Histamine causes the increase in the vascular permeability. So whenever there is in the vascular permeability, that is particularly the blood capillaries, there is squeezing of the fluid from the blood into the surrounding tissue, and when there is accumulation of that fluid in the surrounding tissue, that may cause the edema. Next is the exudation. Exudation is that process that is release of the small droplets form, which is known as oozing. Now again there is effect on the specific gravity. The specific gravity of this is less more than histamine releaser. What do you mean by histamine releaser? Histamine releaser means those conditions, either physiological or pathological, which are responsible for the release of this histamine. They are known as histamine releaser. Now that histamine releaser, that is tissue damaging, trauma. Tissue damaging means trauma. It is responsible for the release of histamine. Stings we know, that is whenever there is the bite of a snake or any other component, then this is known as stings of the renum. That is, they cause there are certain proteolytic enzymes which are responsible for the release of histamine. Phospholipase A. Phospholipase A, you have studied in detail during the phospholipids, that is metabolism of phospholipids, in which I have told you various kinds of the phospholipases: phospholipase A, phospholipase B, C, D, so on and so forth. Now here it is phospholipase A which is responsible for this release of histamine. So then there is antigen-antibody reaction. Antigen-antibody reaction means that immunoglobulin E is antibodies, and when there is antigen-antibody reaction takes place, there is release of histamine, and then we know that condition that there is the formation of the allergic reaction. There is appearance of allergic reaction, so that is antigen-antibody reaction. Now polymers again in carbohydrate, we have discussed in detail about these polymers. That is dextran, polyvinyl pyridine, PVP, polyvinyl pyridine, D-tuberculin, morphine, atropine, and polymyxin B, vancomycin, and penicillin. These are the drugs, these are the components, these are the condition, these are the situation which are responsible for the release of histamine. Now, when there is release of histamine, if it is not inhibited or not treated, then patient may enter into anaphylactic shock, and this anaphylactic shock is the severe type of the allergic condition, may cause the death of the patient. Now that's why there are certain drugs which inhibit the action of this histamine, and they are known as antihistamines. Now particularly they act upon the H1 receptor, and that's why they are known as H1 receptor antagonist. Antagonist means they inhibit the combining of histamine with the receptor. That's why they are known as antagonists. Now the they chemically have the ethylamine side chain. They are having ethylamine side chain. Now coming to the pharmacological action, you know that like every drug, every components, they are also having certain pharmacological action. They have certain pharmacological action. So first of all, histamine antagonist. Histamine antagonist means that they blocks the release of histamine, or they blocks the combining of histamine with their specific receptor, which are known as H1 receptors. So on the basis of that, they causes the bronchoconstriction, contraction of the intestinal smooth muscles, and triple response, that is wheal, flare and itching. Now again, anti-allergic action. Urticaria, you know that it is the allergic condition which arises on the skin. That is, there is eruption of skin, there is itching, there is pain, there is if it is not corrected or not treated, that may cause the bleeding. So then angioedema means there is accumulation of the fluid in the lungs and the heart, fall in the blood pressure. That is due to the vasodilatation, there is fall in the blood pressure, controlled asthma. Now on the central nervous system, depending on the ability to cross the blood-brain barrier. Now again, you know that all those drugs which can cross the blood-brain barrier, they shows the central effect. So again, for these antihistaminic drugs, depends upon the condition, depends upon the property, that whether they are able to cross the blood-brain barrier or not. So depending on the ability to cross the blood-brain barrier, those which can cross the blood-brain barrier, they show the central effect. Which cannot cross or which are unable to cross this barrier, there is no central effect. If crosses, they causes the depression of the central nervous system. and causes sedation. And causes a sedation means the patient becomes sedated. So that is known as sedation. So anticholinergic action also have the antihistaminic effect. Now again, on the basis of their potency, they are subclassified into high activity, highly active, low active, very low active. Means they shows higher activity, lower activity, and very lower activity. So these are the anticholinergic drugs. That is promethazine. In case of high, they are promethazine, diphenhydramine, and phenylamine. Diphenhydramine and phenylamine. Low acting are the chlorophenylamine, cyclizine, trichloroethylene, cyclizine and trichloroethylene. Now very low acting, fexofenadine, acetaminophen and cetirizine. These are the very low acting drugs, act as anticholinergic action because histamine also shows the cholinergic effect. So to avoid that, they are known as anticholinergic drugs. They can be used. Now pharmacokinetics of histamine: absorbed orally, parenterally, metabolized in the liver, excreted through the kidney, that is in the urine. Duration of action is 4 to 6 hours. Duration of action is 4 to 6 hours. But there are certain drugs which are having long duration of action, that is 12 to 14 hours. And these drugs are fexofenadine and cetirizine. These drugs having the long duration of action, that is 12 to 14 hours. Now the side effect of antihistaminic drugs. Now before you know that I have given you the photocopies of all these lectures before this situation or before this when the session was going on. So you are having in detail about all these, but here we are going to discuss the briefly. Now side effects, that is sedation, fatigue, diminished alertness, that patient is not properly alert, there is diminishing of the alertness, then tendency of fall in sleep. So there is, the sleep is not in the control, there the patient having the tendency to fall in the sleep automatically, right? So impairment in the psychomotor performance, that is psychologically patient is not in a proper condition. Restlessness, because due to this all condition, there is patient feels the restlessness, then the dryness of the mouth, because you know they are having the anticholinergic effect. So that's why there is dryness of the mouth, because the cholinergic drugs increases the secretion from the salivary glands. So when there is anticholinergic drugs given to the patient, there is decrease in the secretion of the saliva, or sometimes it is inhibited. So that's why the patient feels the dryness of the mouth. So alteration bowel movement, that is the bowel movement in the intestine, in the large intestine particularly, there is alteration in the movement of the bowel. So due to the involvement of the muscles of the GIT, urinary consistency, there is accumulation of the urine and passage of urine is decreases. Blurring of the vision due to anticholinergic properties, there is blurring of the vision, right? Hallucination, you know that hallucination, that is that condition in which the patient feels the unrequired noise, that is hallucination. Hypotension, decreased blood pressure, convulsion. Ultimately, death occurs due to the respiratory and cardiac failure.